Um, there's a couple people still popping in, but basically, we're gonna start off by talking a bit about some USACO things, and then we're gonna kind of have a preview of machine learning. But also, FYI, if you guys didn't know, this is going to be our last meeting of like 2020 of like this semester, basically. Next week, Wednesday, right? That's the last day of finals, and basically school's out and it's already winter break. So we just decided we're just not gonna have a meeting that day, just because it's the school is basically over. So this is our last meeting. The next meeting is gonna be probably sometime in 2021 in January or something. We'll send more updates as like we get closer to that date. But basically, in case you guys also didn't already know, the first USACO competition is on December 18th to 21. So I believe 18th is the Friday and 21 is actually the Monday. You have like a 4 hour slot between those times to test. And I think there are like maybe some questions about the USACO, especially because it's like a tiny bit new. So if you guys like haven't uh, if you guys haven't like done this before or have like some questions about it, I'm pasting this link in the chat. You guys can check out this article. It's pretty useful. It has like it goes over a lot of like common questions about the USACO. So some important ones I'm just gonna quickly go over is so any student can try to use USACO, and you take it on its website. And when do you take it? There are 4 weekends per year, and it's normally 4 hours. It's sometimes 3 or 5, but from my experience, it's always been 4 hours. Um, Also note you do have to create an account beforehand. So if you haven't already, you can like navigate the site, register for a new account. It's pretty simple. And then how do you start a contest? So when it's like contest day, right? So when it's December 18th and between December 21st, when you log into your account, there's gonna be a like a button on the front page that says like start the contest. So like the page is gonna update on the 18th, and there's gonna be like a different page, and there'll be like a button for you to start the contest. The time format is 4 hours. There is no ability to like pause your 4 hours. You can take a break if you want, but your time is going to continue running. So basically, from once you start, you have 4 hours or however many hours they give you. And after those hours are up, there's nothing you can do. And then it's also completely free. You can't work in a group. You do not have to be in a school team. There are no prizes, but there are some accolades and accomplishments you can put on resumes and stuff. And there's like contest divisions here. We kind of talked about it before. You guys can read it later. How are contests scored? This one's a bit interesting. So basically, there's normally 3 questions, and each question has like a number of test cases. So for example, it's normally at least 10 test cases, and then the 3 questions make up 1,000 points total, with the test cases being divided equally. And then you earn like a certain amount of points for each test case that's marked as correct. So like even if you get half the question correct, like half the test case is correct, that's still pretty good because you still get like half the points. And basically, out of the 1,000 points, you need to reach a certain number, right? That's decided like after, like it's like a percentile basically. And if you reach that number, you'll get promoted to the next contest, next division. And then there's no consequence to doing badly, and you never get demoted. And there's some more stuff here, blah blah blah. This part's pretty important too. They do have like a bunch of programming languages they support, although it is noted that Python specifically is a bit slower, but it's still able to do it. If you do choose Python, you should still be okay. Important note is because they allow for like they allow certain amount of seconds for each language. So although C++ is like the fastest, is like much faster than Java, I think. They give like 2 times amount of time for the Java programs to run. So it still roughly balances out. Most people use Java or C++, and most people in the beginning divisions use like Java or Python, I think. And there's some more stuff here, some more questions. You guys can read through this later. But basically, that's about it. So if you have any like questions about the USACO right now, you can privately message me or message me later, and we can answer them. Also, note when the contest does start. we probably won't be able to answer like specific in contest questions like about the actual contest problems. Though I think we can still help out with like technical difficulties, like if you're struggling to create an account and like stuff like that. But just like don't ask us about the specific questions during the contest, because we can't like answer that. But we'll probably go over the contest questions afterwards, after the contest is over in like January or something. And then so if you guys have questions, you guys can let me know. But basically, there's one more thing about the USACO we need to cover today, which is the input and output formats. So if you see like I/O or IO, that basically stands for input output. And normally the input output we've been dealing with so far has only been system.in and like system.out, or like right your console basically. However, in USACO, you're gonna need to be reading input from a file, and you're gonna be needing to output info to another file. So there's some differences in your code. So if you guys like don't know about this yet, basically all you need to know is the stuff in bold on here. So everything that's not in bold we've kind of seen before. So as you can see, public static void main, right? That's like our main method. And then instead of just putting the brackets, we're gonna put throws file not found exception, comma IO exception. So this first one deals with files, the second one deals with input output. You don't need to know what they like really do. Just know that they're necessary to be put. And then when you create your scanner, normally we put scanner in equals new scanner, then we put system.in, right? So this time we're gonna need to put new file, and then in parentheses in quotations, you're gonna put the file name. So you would replace file name with whatever file the actual problem asks you to do. And then this is a whole new line. You're gonna call print writer out equals new print writer, new file writer, and then file name. Also note that file name here, the first one and the second one, they're gonna be two different names. And then the print stuff, we're just gonna use whatever you called it. So in this case, we created a print writer that's called out, and then we're gonna have to do out.close at the very end to like close the printer basically. It might be a bit confusing, so I'll just kind of go over an example. So I have a blank folder here. We'll create a new file. We're just gonna call it usacoio.java. And then so just to save time, I'm gonna like paste in the code from here. Uh, so hopefully this pasting works. So it did kind of work. Also note that, so obviously this isn't gonna work, right? I need to add everything else. But at the very top of your file, you should always have import java.util.asterisk, and same thing java.io.asterisk. Basically, they just import a bunch of utilities from the util package and io package that you're going to need. Um, all right, so once I paste this in here, the program should be fine. Um, Okay, so basically, now the problem, right? New file name. There's some errors here. That's totally fine. We can fix them later. But first, I'm gonna create two blank files. That's gonna be our input output file. So we're gonna create test.in. .in is just like it's just like format that the USACO competition uses. That's going to be our input file, and test.out will be our output file. They're basically like notepad files, right? They're like .text files basically. So in our input file, we're going to put, let's just put test and then like 1, 2, 3. And then we'll put nothing in this output file because we're going to print to this file actually. And then in here, instead of file name, we're going to replace file name with test.in, right? Because that's our input file. And then with file writer, we're going to replace this with test.out. So now there's like no more errors in our code. And so what we're gonna do is we're gonna grab this input here, right? So we're gonna grab test and 1, 2, 3. So it's identical, right? So we're just gonna call it string test is equal to in.next line. And then int num is equal to in.next int, right? So those are just gonna grab what we have from here. And then to print out, we're going to do the same thing. Instead of system.out.println, we're just going to do out.println because that's what the name of our print writer is called. So out.println, let's just do test plus num. So now if I open up a console and I run this file, So nothing's outputted, right? Because we're not printing anything to that console. Instead, we're printing it directly to the file test.out. So when we check this file, it prints test123, right? Because that's what we told the program to do. We grabbed test, we grabbed 123, then we printed them on the same line. So if we change like 123 and put like 555, and then we run the same program, the file gets overwritten, right, with test 555. And so that's basically roughly like how input output works. And then the very last thing I'm gonna do is we're gonna look at an actual USACO problem. And then we're gonna quickly show like how the input output format works over there. But if you have any questions right now about what I just showed, you guys can message me. So we're gonna go to the most recent contest. We'll go to social distancing 1. So this is a problem. Basically, you guys can read all of these like problem statements here, blah, blah, blah. But the most important thing you need to know is input format. It says file sockthis1.in, and then output is sockthis1.out. So when you see this, basically what you need to do is when you create your file, the first thing you should do is you should just name it whatever that was. So sockthis1.java. And then do the same thing, right, that we always do, right? So we include our 2 import statements. So I'll just kind of speed through this. And then the same thing with our main method. So we'll just paste that in one more time. And then this time, instead of putting like test.in or something, we're going to put sockdist1.in. And then instead of file name or test.out, we're going to put sockdist1.out. And then do the same thing, right? You can grab whatever input and you can print stuff. So just for like example purposes, I'm just gonna print out like test output, right? So we can like know that it actually works. And then we're gonna navigate back to our USACO. So I'm actually gonna log in really quickly. And then I'm gonna log in so I can actually submit the file to like show how it works. All right, so I just logged in. Basically, once you log in, it should look something like this. In the bottom, you can like submit now. When you choose language, these are languages it supports. We're gonna choose Java, right? Because that's the file we have. Then choose file. Let me go navigate, and just want to navigate to wherever that file is. So the file is right here for me. It's called sockthis1.java. Click open, and you're gonna click submit solution. Then it's gonna start grading it. It's normally pretty fast. And then it shows we have an incorrect answer on our sample input, right? And then it says the correct answer is 2, and your output file, sockthis1.out, it printed test output, which is what we told it to print. So that's basically how it works. That's how would you do it during the competition. And that's basically all we have for the USACO preview. So I'm gonna like let Zankai start talking now. But if you have any questions about the USACO, you guys can let me know. And then also, last thing is if you guys like don't plan on competing / don't want to compete, we still recommend you to at least like check out the contest format and what the contest is. So like maybe you have like an extra 30 minutes, just enter the contest, check out the problems, read through the problems, maybe try to see if like you can come up with a solution, then maybe implement the solution, or just kind of get a feel for what exactly it is. And then that's basically it. So I'm gonna stop sharing now.
Okay, so we're gonna do a bit of a demo, and before that, we're gonna do a bit of introduction with a list of FAQ. And so today we're gonna do a classic handwritten digit recognition demo using the library Keras, which is now integrated into TensorFlow. I believe if you've ever like heard of machine learning and stuff, and if you're ever interested in it, you probably heard of TensorFlow. And yeah, but normally you don't. If you're just starting out, you don't have to use TensorFlow because you've got Keras, which is a really nice tool to use TensorFlow, but in a like much simpler format. So there's a FAQ here. So what is TensorFlow? So TensorFlow is a ML framework to be exact, but yeah, so TensorFlow is a machine learning framework, and Keras is a high-level API. And so you don't have to use, so TensorFlow can be a little bit complex if you want to, if you're just a beginner, but so you have Keras to use it in the background. So originally Keras supported like, originally Keras supported like other backends like Theano and I don't know, CNTK, and but right now they it has been merged into TensorFlow, so now it's like TensorFlow only basically. So if you know about other other libraries like PyTorch, which is a like another ML library, and it's a popular alternative, but we're not going to talk about it today. And so you will probably not understand everything that I'm demoing here because we don't probably have the time. Plus, it's just a preview of what is to come. And so just to get an intuition for machine learning, what you're doing is basically you have the library that you're working with, which is for now is Keras, and you want to get some algorithm, get some machine learning algorithm, and train it with data, and then you get a model out. So yeah, that's basically how it works. And you can use the model to process, data. So if you have a image recognition model, maybe it detects whether the image is a cat or a dog. After you've trained it with like a bunch of labeled images with of cats and dogs, you can use this model to basically predict, to process the image and tell whether it's a cat or a dog. So what we can do with ML or machine learning, so can do a lot of stuff because there has been like a bunch of new algorithms in the current decade or in the last decade. Um, so you can do image recognition, which is what we're doing today. You can do audio recognition. Think voice assistants like Siri or Google Assistant. And you can also do natural language, spell the natural language processing. Um, so basically, you use it to analyze text, etc. And you can also analyze videos. That's how YouTube detects, text illegal. That's how they struck down your videos if you ever put some copyrighted stuff in there. And you can also make weird art. No, I'm not sure if you've ever seen of it, but you can actually produce like make images with this network called GAN or GAN. I'm not sure that's how to pronounce it, but you can probably find a bunch of images that's produced with this algorithm on Reddit or something. And you can also do translation, for example, Google Translate. And there's probably a bunch of other applications or like self-driving cars, but yeah, don't have to list them out. And so today we're going to, since we're doing handwritten digit recognition, we're going to use CNN convolutional neural network or the ConvNet, and yeah, so it's basically a high accuracy image recognition algorithm, and it's a type of supervised learning algorithm. So with supervised learning algorithms, you have to use like labeled data. Basically, you need to acquire a data set that has different. So for at least for image classification, like if you want the computer to tell whether this is a 4 or not, you first have to give it a bunch of examples of 1, 2, 3, all the way to you know um, wait from 0 to 9, right? And so after training with all these data, and the so only after training the machine can tell the pattern within them. And so that's how supervised learning works. You have to give it some labeled data, and by labeled I mean you have an image and you actually have a label with it that says that it's a 1 or it's a 4 or something. And I'm not going to go too much into the detail here, but so this is how a convolutional neural network looks like. And so on the left side is the input. So you have a small matrix of 28 by 28 matrix. So they're basically pixels, and yeah, and they're basically grayscale, but here it has colors just to show, just to make the grayscale more visual. So basically, if you ever heard, wait. So basically, a algorithm like this is made up of several layers, and in each layer, it takes the output from the previous layer and do some processing, and then produce some output for the next layer. So at the start, you've got an image, and then you also see that you've got several layers here. So convolution, which takes the image and then applies some type of kernel to it, and then produce some other image. We're not going to cover what it does yet, but basically think that kernel is something that like choose some pixels and then maybe do some calculation based on the based on these pixels, and then it produce a new value in a new image. So basically summarize the information around it into the new feature map. And you also have the pooling layers. So the pooling layers are basically downsampling layers, and you're basically reducing the size of the um, output from the previous layer so that you can like process it easily. Because if you run this algorithm with like high resolution images, it's going to take a lot of computational power, and it's usually not effective. So you'll need and usually the input images aren't really that high res either. So because yeah, you usually don't need them. And so the max point layer basically selects some pixels, and then it picks the maximum value, and then it put it in the new image. And then so after pooling layer, you got another convolution layer, and then have another max pooling layer, and now you flattened all these data into a so you flatten the pixels, the matrix, into a list of values, and then you do a neural network, which we'll explain after the spring break. Yeah, and then after the networks in like so after the computation in the network, you'll finally have a list of probabilities for digits 0 through 9. So the highest the node with the highest probability is the result. So if 9 has like 80% or 90% of probability, and it's higher than all the other ones, then it means that the model predicts that this image is a 9. So yeah, after this explanation, okay, so this is a Jupyter notebook, and so what it does is that you can combine code with text and images and stuff. It makes it's really nice, and like it's often used in machine learning. And so I've uploaded it to the GitHub. So if you want to check it out after after the lesson, you can just do so, and then maybe use Google Colab to open this Jupyter notebook. And yeah, and you can do all this stuff on the internet. I like with Google server, so you don't have to do it locally. But if you want to do it locally, you can follow these instructions. You can just install TensorFlow, Jupyter Jupyter Lab, and then the kernel, the IPy kernel, and the NumPy. And yeah, but you don't really have to do it if you can use Google Colab or AWS. So okay, so here we've got the setup. So So if you're not familiar with it, it's basically basically used in Python because it's used a lot in like machine learning, and NumPy is a like a scientific calculation kind of library. You can work with matrices easily with this library. So that TensorFlow and like many other ML libraries use it, like uses it for sure. So import NumPy, and then you import keras from TensorFlow, and then import layers from TensorFlow, and then you import the plotting library. So we're going to visualize the digits in the data set later. So let's run it. What the heck? Okay, that's not how I intended it. So if you press Shift Enter, it will execute the code, and now you see that this this bracket is numbered, and yeah. So after importing all those libraries we need, we just prepare the data so that we can use it in the we can use it to train the algorithm. And now so we're going to use the MNIST dataset, and it's a very well-known like introductory dataset. It's a bunch of like handwritten digits that are labeled, and what you do is that you split it into like a train and a test set. So basically, you don't want to use all of this data during training, because you want to leave some of them out to test the model and see if it's working correctly. And also, yeah, and also you want to use the test data set to see if the model is overfitting, but we're going to talk about that later. And all of this is just processing. You normalize it, you blah blah blah, and then you convert the labels, the y's. So how to explain it? So basically, in machine learning algorithms, it's better if you convert these labels, so 1 through 9 or 0 through 9, into like vectors. But yeah, this is we don't have time to explain it right now, but just know that we need to do that. And in keras, you use the two categorical function to achieve that. And let's just execute this block of code. Yeah. And by the way, you can view a set of shortcuts using the H key. So this is a set of shortcuts. So we've prepared the test data, the training data and the test data, and we can visualize it by using the matplot library. And so here we just basically we get the first 9 images of the training data set, and we plot it using matplot. Don't have to worry about what this code means. We'll cover it later probably, but we can just execute it and see how it looks. So yeah, they're basically grayscale images, nothing special. And so in every so after we've prepared the data, we can build the model, the model that, well, how do I explain it? So yes, so in order to train the model, we have to specify what the model is made up of. So in this case, it's basically all these layers: convolution, max pooling, convolution, max pooling. You flatten it, and then you have a neural network, and then you got your results on the right. So basically, we just have to put that into code, and keras is very easy to. It's very easy to do it in keras because it's basically just an array of layers, and have convolution max pooling, convolution max pooling, blah blah blah, and then you put the configuration for each layer in the arguments, and that's about it. I'm not going to go into too much detail, but it's basically the previous image in code, and we can see what it returns. So the model.summary basically prints the model. Yeah, it's basically the previous image, nothing special. So now that we've got the training data and the model set up, we can we can train it now. So first thing we do, we have to compile the model, and when you compile the model, you have to specify what type, or how, like you have to specify how you want to train the model, and like what loss function you're going to use, and optimizer, and what metrics you want to see during training. Yeah. And when you actually train, use the fit function. And so I'm not sure if I want to go into batch size, but you can safely ignore them for now. We're just going to train the data. We're just going to train the model on the data. So I shift enter. This may take a while. This will take a while. If it doesn't finish in like a few minutes, you can just leave because there's not really much after it. Yeah. And I'm running this locally, but usually you probably want to run it like on, AWS, or if you're just starting out, you can use Google Colab, because they've got like computer that's actually made for this. Like right now I'm using CPU because I don't have a NVIDIA GPU. So, well, and you can only use NVIDIA GPUs that has CUDA, like to do machine learning. So, well, so usually you don't have that much training data, and to save time and resources, so that you don't have to acquire so much training data, you can basically repeat the training on the same data like a bunch of times, and that's what epochs means. So yeah, right now we're repeating the training process 15 times on the same data. So yeah, that's 15 epochs. And also each time, so the algorithm, the model processes like, it doesn't process single images, it processes a batch at a time. So that's what the batch size means. So basically, it only processes 128 at a time. And yeah, that's because GPUs can, so if you use GPUs, they can process like they can do matrix calculations very fast. So that's why you want to have matrices. Yeah. And so if you know a bit about this, you'll know that it's basically calculus. Well, for SGD it is, but probably, well, yeah. Let me reword this. So basically, every time you for every iteration, so every time it runs, every time the number increases, it probably use the loss function to determine how bad the algorithm is doing, and then it use the optimizer to improve the model, and probably use some calculus because I'm rusty on this. Yeah. By the way, you don't have to wait till it ends because yeah, if you want to, if you have to leave, you can just leave. It's okay. There's nothing much afterwards.
Wait, Zenkai, are you talking? Wait.